Definition of a derivative at a point. Let's go through this worksheet. So this first one, which lines are tangent to the curve? So remember, tangent means going to hit at one spot, but that's kind of like bounce off. Like right here, that's a secant line more. Like if you want to continue this, it's going to cross it twice. Like that one crosses twice. So the only ones that are tangent are A and D. Little geometry review. What are the two ways of writing the difference quotient? So again, since memorization, the first way to write a difference quotient is f of a plus h minus f of a all over h. And then the other way to write a difference quotient is f of x minus f of a over x minus a. Right, this one's just like the basic slope formula, y2 minus y1 over x2 minus x1. And this is a little bit more fancy. It's I think the difference quotient is this. I just think that it's slope, but it's kind of the same thing. For which value of x is f of x minus f of 3 over x minus 3 equal to this? So it's basically just saying, what is x that gets you this thing? Well, so I just look at it. So it goes 3, 3, right? X turns into 7. And 7 minus 3 would also be 4. So x is 7. Don't overthink that one. So which of the following quantities represents, what do the following quantities represent in terms of the graph f of x equals sine x? So this wants to know like what's going on here. So if you look at like sine of 1.3 minus sine of, like, I mean, we don't have the sine graph here. I could draw it real quick. Not really going to help really though. Goes on forever. Sine of 1.3, let's say this is 0.9, this is like 1.3. It's probably totally off. But what's the difference of this and this? Well, these are like the y values, right? Remember, like this is 1.9. Sine of 1.9 of 0.9 would be this guy right here. And this point right here would be sine of 1.3, right? The x values are just the numbers itself. When you plug it into the function, the sine function, then you get this value. So it's just like saying y2 minus y1, or the difference in height. Lots of ways to say that. The difference in height between the 2 points, Right, difference in height are also known as delta y. How about the next one? Well, we get the difference in height when divided by 0.4. Where do they get 0.4 from? Well, look at the numbers you have. 1.3 and 0.9. That's just saying, this is another way of writing 1.3 minus 0.9. So, what is that? That's a difference quotient. But what is that mostly known as? It's the slope of the secant line between 2 points. Right? Because you have 2 points, so it's the slope of a secant line. The tangent line only has 1 point. So there we go. F prime of 1.3. So that's the definition, right? What does F prime mean? That means the slope of the tangent line. To the curve at x equals 1.3. Moving on. F of x equals x squared plus 9x at a equals 0. Find f prime of a using both versions of the definition of a derivative. So, right, definition of derivative is just a difference quotient applied to, let me take a limit of difference quotient. That's what derivative is. Derivative. So I set it up for both of us here, right? So here's the one way of doing the limit quotient, the difference quotient. Take the limit of this one. Now our a is 0, so we're plugging 0 in for all these things. And all we gotta do is just continue on that. So we're gonna take the limit as h approaches 0 of, let's do f of 0 first. So what does that mean? We're going to plug 0 into this function here, x squared plus 9x. I plug 0 in, I get 0 squared plus 9 times 0, which is just 0. How about the other one? F of 0 plus h. So a lot of people freak out with this. Literally f of 0 plus h just means plug in 0 plus h. So instead of x squared, I'm going to get 0 plus h squared. Instead of 9x, I'm going to get 9 times 0 plus h. If I simplify that, what's 0 plus h squared? Well, it's just going to be h squared, right? 0 plus h is just h, square it, h squared. What's 9 times the quantity 0 plus h? Well, that's just going to be h, so 9h. So we get this, h squared plus 9h minus 0 over h. Keep on going. Well, this is just h squared plus 9h over h. Look what happens. You can factor the top. Right? So all I did was plug it in what I saw. Got to here, simplified a little bit. That was like a waste of space. So I got this. I factor out the h on top. They both have it. And now these reduce. And we have the limit as h approaches 0 of h plus 9. Sub in that 9. You just that 0, sorry, for h. So we'll plug 0 for h, and we just get 9. So that's the answer. So that's doing it this way. That call it the limit. That's the limit definition of a derivative. So you just took a derivative using the limit definition. We're going to do the same thing using the alternate version of the difference quotient. So this way. So same idea. So you have x minus 0 of f of x minus 0. So now f of x is literally just f of x. It's right, just that guy. So that's just going to be x squared plus 9x. F of 0 is just what f of 0 is, like we talked about before. Plug in 0, right? You get 0 squared plus 9 times 0, which is just 0. So if I rewrite it, I'm going to get this, x squared plus 9x all over x, right? The 0 went away, the 0 went away. I get this. Hey, it's just like we had it over here, but just instead of an h, it's an x. So we're going to do the exact same thing. Hey, they both have an x, let's factor it out. Remember, you cannot just cancel. That's terrible. You can't cancel that way either. You have to factor, then cancel. Right? This is like stuck together. It's a plus sign. So that means it's an implied parentheses. You know, you don't see it. That's what it is. So you can't cancel out because it's stuck inside the parentheses. So now let's factor out the x. One of my worst x's. So I get x plus 9 over x. These reduce. So you get the limit as x approaches 0 of x plus 9. If you notice, I keep on writing the limit because we're still taking the limit. Once I sub it in though, then I could stop. So now it's just 9. So I don't have to write it again because I took care of the limit. So it's just 9. So either way I get the same answer. Next one. So for 8 and 10, we're going to refer to this figure right here to solve the questions. So compute f of 2.5 minus f of 1, 2.5 minus 1. What quantity does this represent? Well, it's the difference quotient, or the slope of the secant line. So anyway, I want to say that. But let's do it. So here's 1. F of 1 would be just follow the graph. So about, let's just say 1 as an estimation. Here's 2.5. Go up to there. Looks like we get about 2. So we want to compute that to be 2 minus 1, which is 1, over 2.5 minus 1, which is 1.5. So 2.5 over 1.5, if we want to do that, we could write this as 1 over 3 halves. So that's 1 divided by 3 halves, which is just 1 times the reciprocal. So 2/3. Again, what does it represent? It represents the slope of a secant line. So if you draw a line through here, that'd be a secant line because it's 2 points, and then that would also be the slope of it. You just found the slope. So slope of secant line. He thinks it's a secant line. Okay, let's estimate f prime of 2. So I'm going to change my color here. So remember, f prime of 2 is the derivative. So it's the slope of a tangent line at 2. So here's 2. So we're going to do we're going to estimate and that's why I still said estimate. We're going to try to draw a tangent line on this thing at 2. So that hits it just once. So something to this effect. That's my derivative at 2, so it's my tangent line at 2. Now we want to find the slope of it. So you just pick 2 points, like right there, and let's say this right there. Again, it's an estimate. There's going to be lots of different answers. They all should be kind of positive though. So I picked these 2 points. So based on those, if I run 3 spots, I guess 1.5 spots technically, and I go up 2 spots, I get approximately 2 over 1.5, 2 over 3 halves, 2 divided by 3 halves, 2 times the reciprocal, so 2/3. So I get 4/3. And again, that's just an estimation. You get something different. It all depends how you drew the line. Just an estimate. So there's that. Next one, very, very similar. So we're going to use this for 11 to 13, so for all of these. So f prime of 1. Well, here's 1. If I draw a tangent line at 1, it's going to be the exact same thing. Just be the exact same line. So what's the slope of a straight line? 0. Tangent line at 2, same thing, 0. Tangent line at 4, now you get interesting. 4 is right here. So how do I do that? Well, you just look at that line there. So you just find a slope of this line here. You do rise or run. 1 and 2, so 1/2. Right, so you can just use the line right there. Slope of 7. 7's right at the cusp right here. And if we should learn by now, that makes a so at any hill or valley is always 0, because it's a tangent line. So there we go. So again, slope at any of those like peaks is always going to be 0. Now we want to estimate the slope at 6. So 6 is right here. So that's a curve. That's what they estimate it. So get a little picture out here. 6. Draw a little tangent line to it, roughly. Not my best tangent line. Pick 2 points. I always pick the point we start off with. And then something else that crosses nicely. Oof, that's a rough one. I'm going to pick that and just kind of move with it. I'm going to say it's 1 and 1. Slope of 1. I'm going with it. Which is larger, 5.5 or the slope of 5.5? Need to erase some of this. Okay, so I want the slope of 5.5. So 5.5 is right here. So kind of like this. And then the slope of 6.5. Okay, so those are the two slopes we're talking about. Which one's larger? Well, again, so larger, we're talking about slopes here. So larger means steeper. Positive steeper, I would say. If it's a negative steep, then it's actually like, who's less steep? Like, whatever. In this case, since we're talking about positive numbers, which one's steeper? And that would be the purple one here. This is 5.5. So this one is larger. Moving on. So these we just want to take a derivative. Just straight out take a derivative, don't need to look. What do all these have in common? They're linear lines. So taking derivatives is actually really, really easy. We don't have to go through all the mess of doing the stuff we did up here, of doing the limit definition. I just want you to look at it and go, what's the derivative? Now we're talking about derivative of a linear line. The derivative is always the coefficient. So in this case it's 3. 16, there is no coefficient. This is a constant. So derivative of a constant is automatically 0. Just like what we did up here, right? If it's a constant, the slope of the tangent line is going to be 0. Straight line across. Where these are like that. So the slope is just the actual slope. The next one, 9 minus t. So it's the constant there, so -1. Over here, same thing, would be the 16. Again, that's all that's going on here is if you draw the line, there you go. Okay, plus 9, slope is 16. So up 16 over 1. And I'm saying, hey, what's the derivative of this guy? What's the slope of this line there? Well, we just did it, 16. So that's why it's 16. So now we're going to go backwards. Each limit represents a derivative, f of a. Find a and find f of x. So we're saying, like, here's the limit definition of derivative. What is a and what's the function we're talking about? So based on this function here, a is always the number next to your h. So my a here is 5. F of x is like kind of this part right here. Like, take away the 5 plus h, take away the blah, blah, blah plus h. What's left over? You have a function cubed. Like that. And you could, and to check your work, you can always plug this into the function and you should get this guy. Right? 5 cubed is 125. That is what this is. Because remember, this point right there is f of a. So if you did it right, that should work out. So if I plug 5 into there, I get 125, which is right there. So that's one version of the limit definition. What about the other version? This one's even easier if that's possible. If you remember this definition, it's f of x minus f of a over x minus a. Well, I want a, so right there, 5. And I want f of x, well, right here, x cubed. Could it be simpler? Next one, this is where it's more fun, right? Where it's not just given to you. What's my a? Remember what I said before? It's always, this function, this definition's like this. Right, so what's my a? It's always the thing next to your h. So my a here is pi over 6. F of x, so you want to look at this guy, but ignore the a plus h, like what is the outside function? That'll just be sine of like an x. So there we go. Moving on with 2 more of the fun ones. So again, remember the way this one works is it's f of a plus h minus f of a all over h. So what's my a? It's the thing next to your h. In this case, that should be 2. By the way, we'll go back to that in a second. Let's read it. What's f of x? It's this thing, but kind of ignore the a plus h part. Like make that an x. So it'll be 5 to the x. This is about to say, almost forgot, how do you check your work? Right here, right? F of a. Plug this into that. Do you get this guy? If I plug 2 in there, I get 5 squared, which is 25. So it does work. And that would have worked up here also. I should have done that. Plug pi over 6 to sine. Sine of pi over 6 is 1/2. So 30-degree triangle. So 0.5. Okay, last one. The limit as h approaches 0 of 5 to the h minus 1 over h. So same idea. Remember the formula? It's f of a plus h minus f of a. So in this case, I don't see anything next to the h. What does that mean? 0. It's an ugly 0. There we go. So remember, 0 plus h gets you just h. So if you don't see anything next to the h, it's a 0. Okay, and then what's f of x? Remember, just ignore the h part. So it's 5 to the x. Does this thing follow? If I plug this in there, do I get the 1? Yes, you do. 5 to the 0 power is 1, so it checks out. That's a worksheet.